Hey everyone, welcome to week 2, day 5, or the 10th day of non-traditional instruction. I want to let you know that the 7th grade math team is with you. If you need anything, make sure you're reaching out to us and letting us know, math or otherwise. Email or Google Classroom is going to be the best way to get a hold of us, parents or students. So make sure you're reaching out, even if it's just a check-in, need somebody to talk to. Before we get started, I want you to go ahead and grab a piece of paper, a scratch page, whatever you've got laying around, and a pencil so that we can continue to commit these starters, as knowledge and memory that we can pull from. I'll give you a few seconds to get that done. All right, the spinner is spun twice on number 1. What is the probability of hitting a 7 first and then hitting a striped? Well, so I need to do the probability of 7 and then stripes. Now, on your reference page, there's a section over independent versus dependent events. Independent, this is an independent situation because me rolling a 7 has no effect on the probability of me spinning a stripes. They're completely independent of one another. Wheel of Fortune, you spin a big spinner and then they take that thing off the board. If it's like a prize, that would be dependent because no one else can win that square again. But we're gonna keep 7 on this spinner, so that would make it independent. We need to come up with 2 fractions and then we'll go from there. So I need the probability of spinning a 7 and then spinning a stripes. So on your class kick, it's going to be kind of structured like this. You're looking for spinning a 7. There are how many 7s here? 1 out of 10. So you're going to go 1 out of 10 for the first fraction for 7. Go straight here. And then for stripes, I've got 1, 2, 3, 3 out of 10. And then you simply multiply straight across because fraction multiplication, you're going to multiply your numerators and multiply your denominators. Now, may you have to simplify? Sure. Could maybe you could cross simplify here because you can cross simplify when you find a product of 2 fractions. Absolutely, you could do that. In this situation, there's no cross simplifying to be done. We're going to go ahead and get 3 out of 100. So that means at 3 times out of every 100 double spins would you get 7 and then a striped, which is very unlikely. So you could put that as 3% or 0.03 or 0 and 300ths. So those are possible options. We're going to keep ours a fraction just because we know we're good, we're simplified and ready to go. All right, let's jump over to number 2. It says a deck of game cards each have a different shape on them: 12 diamond, 8 square, 5 circles. What is the probability of drawing a circle, replacing it, and drawing a diamond? Guys, there are 2 words in this question that are maybe the most important of everything. Every other word in here. Replacing it. If I pull a card out and I replace it back into the deck before drawing my second, that makes them an independent. They make the 2 events independent. So this is another independent event or set of events. Independent. Okay. So I need to find my probability. It says what is the probability of circle then a diamond? So probability of circle then diamond. Okay. So there are 5 circles, and then so that's going to be my top, the desired outcomes, and then that's going to be over my total possible outcomes. So it's going to be 12 plus 8 is 20 plus 5 is 25. Now, could I simplify here? Absolutely. As a matter of fact, I will. I will probably rewrite that out, and you may need to do that for class kick. So diamonds is 12 out of 20. 12 out of 20. So let's go ahead and simplify those all the way down. So 5/20ths, they both share a factor of 5. So 5 divided by 5 is going to get you 1/5. And then and then 25 divided by 5 gets you 5, sorry. And then 12 and 20 share a factor of 4. 12 divided by 4 is 3, and 20 divided by 4 is 5, so we're in good shape here. There's no other cross simplifying I can do, so we're just going to multiply straight across as we did on question 1. 1 times 3 is 3, and 5 times 5 is 25. So 3 out of 25 times we would expect to, on a double pull of a card, that we would pull a circle and then put it back and then pull a diamond. It'd take that 3 times out of 25. Again, you could go decimal or percent on that one, but I think this is probably a better rounder number. Let's go to question 3 for our final question for today. It says the letters of the word classroom are placed in the bag. What is the probability of randomly drawing an M on the first draw? Again, most important 2 words in here, replacing it, and then randomly drawing an S on the second draw. Alright, so the reason this is also independent is that we're able to pull the M again on the second. And it's still out of 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's try that again. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would be we need to probability notation. We've got probability of M on the first draw, then S on the second. Well, fractions again, so we're going to look at M, how many M's there are, and if I do that, that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 out of 9, and then how many S's, so that would be 2 out of 9. There's no cross simplifying to be had. If I didn't replace that M on the first draw, that would change this to 2 out of 8, because there would be 1 less tile. That's why the replacement is so important. We're going to go ahead and multiply straight across. That'd be 2 over 81. That doesn't simplify. You could do decimals or percents to also change it to a different form, but I'm going to keep it here. Guys, it's been a good week. If you have any questions, make sure you shoot us a message. Hope to see you soon.